nowadays another important tools, not in Python. This is a Microsoft product. The market is booming. That is Power BI. Hmm? Using Power BI, you can visualize the data also very easily. All of you can try it. Achha, next. Till now, we learned what is NumPy, what is pandas, and how to visualize the data. Now I want to discuss about some part of the AI and machine learning. Remember one thing, don't think that in case of NumPy, pandas and matplotlib, that's all not like this. When we are working with AI data analysis, okay ma'am, just wait. Achha. Okay. When we are working with AI, data science, or maybe using AI later, when we develop a machine learning model, at that time we use NumPy, pandas, and the matplotlib, all the things, just to learn how to working with NumPy. Till now we learn how to working with NumPy, how to working with pandas, how to working with matplotlib for visualizing the data. Obviously, when we are working with AI data science, at that time we need to use different types of data visualization process. Before that, today I want to start discussion about the AI and data science and machine learning also. In the previous session, I discussed about it. In the previous session, I discussed about what is machine learning model and what is AI. Can anyone tell me? In the first session, I discussed about what is model, machine learning model, and what is AI. Can anyone tell me what is AI and what is machine learning model? Here a ball. What is AI and what is machine learning model? Anyone? আরে ভুল হলো বল না কিছু একটা, মানে ফার্স্ট সেশনে আমি ডিসকাস করেছিলাম, মনে আছে তো? অল অফ ইউ রিমেম্বার দিস? কি
মডেল মানে আর কি ডেটা ওটাকে ট্রেন করে দেন রেজাল্ট আউটপুট হিসেবে আমরা পাচ্ছি।
হ্যাঁ, ভেরি গুড। এন্ড হোয়াট ইজ এআই?
এআই স্যার টোটালটাকে নিয়ে যে কাজটা হচ্ছে সেইটা এআই হচ্ছে আর কি।
No. Any other student, rest of the student, what is AI and what is machine learning model? Before learning AI, we need to know that where we implement AI, isn't it? Because here we practically use all the things. We create machine learning model. When we create machine learning model, at that time, we need to use the artificial intelligence. Isn't it? Why? Acha, I repeat once again. সবাইকে বলছি, যেগুলো বলছি সেগুলো কিন্তু দারুণভাবে ইম্পর্ট্যান্ট ইন কেস অফ ফ্রেশার্স, when you clear your campus exam. After that, I think all of you got a call for HR technical round of interview. In case of HR technical round of interview, the project is very much important. And nowadays, as per my previous students' feedback, the most of the cases they ask the candidate come with a machine learning data, any next data science project. In case of data science project, don't think that they give you a task, write a code. No, never they give you a task to write a machine learning code. They ask the question related with the AI and data science. What is the functionality? Huh? So all of you be prepared for that. And note down the question. When I ask the question, maybe in my class all of you got an idea about it. But remember the question, and in future maybe forget it. Just go to the Google search engine, put the question, just check it. Okay, what is the answer? I think within a moment anyone can guess it. Okay, what is this? Actually, when we are working with Python program, at that time we create machine learning model for predict the result, and artificial intelligence AI algorithm enable our model to calculate or process the result. Actually, when we create, what is the inspiration for creating the machine learning model? Actually, programmatically, we create a mimic of the human brain. In the first session, I discussed about it. What is the meaning of this? Maybe you see an object. By observing the object, maybe you see a tree. Then you say that, sir, that is a banyan tree. How can you say that that is banyan tree? There are different species of trees, isn't it? So how can you predict that this is a banyan tree? Obviously, you have some past experience. Previously, you saw that type of tree. Previously, when you saw that type of tree, at that time, maybe your parents, maybe some of your friends, maybe some of your teacher told you that is banyan tree. First time when you saw that type of tree, at that time, what you do? You collect some special feature from that tree object and store it in your brain. And at present, when you see the same type of object, at that time, based on the past experience, you predict that, yes, it is banyan tree. If you don't have any past experience, is it possible to predict that what is the name of the tree? No. So when we create our machine learning model program, at that time, after creating the machine learning model program, always you need to train your model using some data. Obviously, if you want to predict the weather, at that time, you need to train your model using the weather data. If you want to predict the stock price, at that time, obviously, you need to train your model using stock price data. Okay. That's why when we are working with machine learning model, at that time, obviously, we need to extract the data based on your requirement. And after training, just we pass the input into our model and our model predict the result. That is the scenario. Now there is a question, how model process the result, calculate the output, predict the output. So in the previous session, I give you an example. Maybe uh, tell me what is the value of that? What is the value of this? Obviously, this is a foolish question, but think in this way. What is 5 and 3? 5 and 3 are the data. What is plus and minus? These are the operators. Actually, using this symbol, what we do? We represent the relationship between the data, isn't it? Based on the relationship between the data, we sometimes we use addition mathematical rule for calculating the result. Sometimes we use subtraction mathematical rule for calculating the result, isn't it? Why we use these mathematical rules? Because Previously, when our teacher teaches us, at that time, they train our brain using the mathematical rule. They use some data using operator represent the relationship and and train our brain using some mathematical rule. Without mathematical rule, is it possible to calculate or process the result by our brain? No. Same thing, when we create our AI model, machine learning model, at that time, at the time of training, we need to train our model using some mathematical rule. And all the mathematical rules are provided by artificial intelligence. So, what is the functionality of artificial intelligence? Actually, artificial intelligence using AI, artificial intelligence enable our model to predict the result. Now it is clear to all what is the functionality of AI and what is machine learning model, why we need to train our model using some data, and when we train our model using some data, at that time we need to train our model using some mathematical rule, and what is the functionality of AI. Now is it clear to all?
Yes, sir.
Yes, sir.
তাহলে এবার বলতে পারবি তো এরকম কোশ্চেন জিজ্ঞাসা করলে?
Yes, sir.
আচ্ছা, next, I think all of you know that there are different types of data sets. Different AI algorithms are available. We need to know that where we need to use which AI algorithm. It is very difficult process. There are different types of data set. There are different types of AI algorithms. And based on the relationship between the data, we need to use any one AI algorithm. Now we need to know that where we use which AI algorithm. After that, we learn what is the background of this AI algorithm, isn't it? Maybe think in this way. In the previous session, I give you this example. You are working as an HR manager. I think all of you know that what is the functionality of HR manager? They recruit the human resources. Maybe the interview process going on. There is a very good candidate, technically strong. They selected in case of technical test. At last, at the time of HR round of technical interview, you ask the candidate, by observing the resume, you check that the experience of the candidate 2.3 years. What is the experience of the candidate? 2.3 years. And at the time of interview, you ask the candidate what is his or her expected salary. Maybe the candidate told you that is maybe 60,000. Now as a HR manager, you offer this salary to that candidate? No. First of all, you need to check that whether this salary support your organization salary structure or not. What is the meaning of this? Means, think in this way, maybe there are some existing employees, already কাজ করছে, existing employees with same experience. Maybe the existing employees earn lower salary than that. Obviously, at that time, if you offer this salary to that new candidate, there will be a problem. Same thing, the same experience existing employees earn the more salary than that, then also there will be a problem. If you offer this salary in future, there will be a problem. That's why what you need to do, you need to calculate the best fit salary for that candidate, isn't it? How to best fit salary means what will be the salary for that particular candidate. So at that time, obviously, you think that if you got the data, all the employees' data from the employee management database. At that time, you calculate the salary easily because in the employee management database, employees' ID, email, gender, contact number, their experience and salary, all the values are available. But remember one thing, here, what we need to do, we need to calculate the salary based on the experience. Don't think that the experience depends on salary. No. Actually, salary depends on experience. What is our problem statement? We need to calculate the salary based on the experience. So here, what is experience? Experience is the feature. What is salary? That is the output. So based on the problem statement, we need to know that how the output values, means salary value, depends on experience. So here I collect some data from employee management database. Maybe this is the data set. Maybe this is the data set. Yeah, I think all of you got it. Based on my problem statement, what is the main important feature over here? Email ID, contact number, gender are not the important feature, isn't it? Experience is the feature over here. And what is the output? The salary is the output. Okay. That's why I collect only the year of experience values for existing employees and their salary. Okay. Now, if you observe the experience and salary, by observing the experience and salary, it is very difficult to calculate the salary for 2.3 years experience candidate, isn't it? But if we use a machine learning model program, very easily we predict the result. At the time of creating the machine learning model program, we need to train our model using this data set. Why? If we train our model using this data set, our model experienced for that type of data set, isn't it? So,
Yes, sir.
when you think in this way, at that time, maybe this is our data set. Maybe. Maybe this is our data set. Okay. I think all of you know that how to read the data from the CSV file and organize the data in a data frame. After that, just now we practice some program using the iLog method. I think all of you got an idea how to extract the data from that. Just for representing this, I just copying some part of the data. Just wait. Maybe I copying some part of the data. I think all of you know that how to extract the data from the CSV file and organize the data in data frame. After that, I think all of you know that how to extract the feature and the output using iLog or maybe log method. Just now we learn all the things. Maybe list of experience values stored in the variable y x and list of salary values stored in the variable y. Here, x is the feature. And what is y? Y is the output. Okay. So if you observe the feature and output, when x equal to 1.1, at that time, what is the value of y? 39343. When you are working with any data set for implementing the AI and machine learning model, at first you need to observe the data. When x equal to 1.1, at that time salary 39343. When x equal to 1.3, at that time y equal to 46205, 46205. When x equal to 1.5, at that time y equal to 37731, 37731 in this way. So there are list of x values and list of y values. And if we observe the x values and y values, when the x value increased, at that time y value increased. But don't think that the rate of increase of salary not equal, isn't it? But increasing. And all the y values are some continuous value. If you change the x values, y values changed. Okay. So based on the list of x values and y values, I think all of you got an idea using which equation we represent this relationship. I think all of you know this equation. The equation is mx plus c equal to y, isn't it? That is called a linear equation. Sorry. That is called a linear equation. I think all of you know that. To solve this problem, why we use linear equation? Using linear equation rule, if we calculate the value of coefficient m, that is called coefficient, that is called intercept. If you calculate the value of m and c, after that you can calculate the y value for any x value, isn't it? And here we observe that why we use linear equation. I repeat once again. When the x value increase, the y value also increase. Maybe the rate of increase not with same proportion, but the salary increase due to the increase of experience. That's why I represent this relationship between x and y using the linear equation. So using the linear equation from the existing list of x values, existing list of y values, if we calculate the value of m and c, after that we can calculate the y value for any x. If you know the value of m and c, obviously you can calculate the y value for any x value. So based on the problem statement, at first you need to check the relationship between the feature and output. Here, as per my program example, maybe there is a single feature. But don't think that every time there will be a single feature, not like this. There may be more than one feature also. Like maybe in case of, maybe if you think about the salary depends on department name, the development, testing, salaries are different. Department name, number of global certification, and year of experience, isn't it? So sometimes you got more than one feature, but as per my problem statement, my example, there is a single feature and the output, that is salary. Okay. So At first, we think about the relation between the feature and output. After that, what we need to do, we need to train our model using linear mathematical rule. Linear mathematical. Next, when we think that they are linearly dependent, after that, we need to train our model. When we train our model, don't think that when we train our model, at that time, you need to know that what are the training processes, learning processes provided by the AI data science and machine learning. What are the learning processes to train our model? Category of learning. In the previous session, I discussed about it. I repeat once again. Uh, One is supervised learning. In case of any data set, if based on the problem statement, if all the output values are available, at that time, what we need to do? At that time, you need to use the supervised learning. I repeat once again, very important. Based on the problem statement, we need to collect the data, generate the data set. In the data set, any type data, based on the problem statement, if all the output values are available, at that time we need to use supervised learning. Supervised learning category. So if I note down this, if all the output values means values available. So output, as per my problem statement, what is the output? Salary values are output. Okay. So at that time, we need to use supervised learning category. And in the previous session, I discussed about it. Another type of learning process, that is unsupervised learning. When we need to use unsupervised learning or training process, supervised learning. If no output values available, If no output values available, at that time we use unsupervised learning. Later we discuss about the unsupervised learning process and what are the AI algorithm available under the unsupervised learning. Another one, the semi-supervised learning. Semi-supervised learning. Remember one thing, every learning process provides us different AI algorithms. What is semi-supervised learning? When we need to use semi-supervised learning process, if maximum max output values not available. If maximum output values means the scenario is like this. Maybe in any data set, like that. The maximum output, one or two values are available. At that time, we need to use semi-supervised learning technique. And remember one thing, note down this. If the minimum number of output values are not available, means one or two values are not available, at that time, we use semi-supervised learning? No. That is called a missing value. Some of the values are missing. Obviously, how to handle the missing values? Machine learning provides us different technique to handle the missing values. Don't think that at that time we need to use semi-supervised learning. No. So need to remember this. What is missing value criteria? And another one is reinforcement learning. In case of reinforcement, what is reinforcement learning? Reinforcement learning. If only available, output available. What is the meaning of this? Means, think in this way. Maybe you want to create a robot. When you create a robot, at that time, maybe at that time, at first, what we decide, what will be the output of the robot. But we don't know which features we need to add to create this robot. So at that time, what we do? At that time, we create a robot using trial and error method. We add some feature. After that, we observe that whether our robot working properly or not, working as per our output or not. And remember one thing, when we add any feature into the robot, at that time, what is happening over here? At that time, from the feature, robot got experienced. Features are just like an agent. From that agent, uh, got experienced. That is one type of reinforcement learning. Okay. Now, in case of supervised learning. In case of supervised learning, there are two subcategories. One is regress. One is regression. When we use regression in the data set, if all the output values are continuous value, what I say, if output values are continuous. So as per my program example, all the output values are available means supervised learning, and output values are continuous value. So we need to use supervised regression learning provided AI algorithms to solve this problem. And another one is a classification.
Sir, what do you mean by continuous?
Continuous means that for each x value, there is a different y value.
Yes, sir.
But if the data set looks like that, let's see. Achha, maybe I give you a simple example. Just right. By observing any person, how can you say that if the person is good or bad? When we meet with any person, at that time, by observing the person, at first we predict that whether the person is good or bad. After that, we continue to talking with that person, isn't it?
Yes, sir.
When we predict the person, how can we predict that whether the person is good or bad? Obviously, based on our past experience. Previously, we meet with multiple persons. Based on that past experience, at present, when we meet with any person, based on the past experience, we predict this person whether the person is good or bad. Maybe the person good or bad depends on some features. These are the past record. Maybe any value. Feature 1, this is the feature 2, this is the feature 3, maybe this is the feature 4, and that is the output. If for some feature value, F1 is something, F2 is something, F3 is something, F4 is something, for actually this feature represent a single person record, what will be the output? Maybe good. For some feature, this person may be good behavior. For some feature, this person bad maybe. This person may be good. This person may be bad in this way. And each row represent the categorical feature of a single person. If any person, if these features are available in any person, then this person behave like a good person, isn't it? Every record represents a single person data. Actually, when we visit with multiple persons, multiple good person and bad person, at that time our brain trained for that type of data set. After that, at present, when we meet with a new person, based on the past experience, we predict the new person whether the person belongs to good person or bad person, isn't it?
Yes, sir.
So at that time, if you observe the output values are continuous value. No, there are two types of output, good or bad. Means inside our brain, there uh, there are two classes, good class and bad class. Some person belongs to the good class and some person belongs to the bad class. When a new person comes, obviously using some mathematical rule, using some AI algorithm, we predict the new person whether the new person belongs to good person or bad person, isn't it?
Yes, sir.
So if you think about the type of the output values are not continuous value. The output values are discrete type. If the output values are that type, at that time we need to use classification. And so when we use classification, if output values are discrete type, at that time we use the classification. And remember one thing, supervised classification technique provides us different AI algorithms. Using this AI algorithm, we solve the classification problem. Here, is it clear to all?
Yes, sir.
Okay, I copy paste it in your WhatsApp group. Observing this, you got an idea about it. Acha. Now, as per my problem statement, obviously, I think all of you got an idea about it. Here, we need to use supervised regression technique to train our model. Actually, what is happening over here? In case of machine learning model program, here to solve this problem, we use linear equation to train our model, and we need to follow supervised regression technique. The supervised regression technique using linear method already implemented as a class. The class name is linear regression. Okay, already implemented as a class. What is the functionality of that class? Actually, when we train our data using the linear regression technique, if it is a model, actually our model calculate the value of M and the value of C. How it will calculate the value of M and value of C? Can anyone tell me how, in case of linear equation, can anyone tell me in case of linear equation, how we calculate the value of M coefficient and the value of intercept C? Can anyone tell me how to calculate the value of M and value of C from existing list of X values and list of Y values? Anyone, any idea? If the linear equation equal to mx plus c equal to y, no idea. Acha, do you know what is variance and what is covariance? এরে একটা হ্যাঁ না উত্তর দে।
স্যার করেছিলাম, অতটা খেয়াল নেই এখন আর। আমি করেছিলাম।
তাই তো ভুলে গেছিস, মানে তোরা টাচে নেই বলে। Remember one thing, everywhere there is a mathematical background. Huh? So whenever you learn any mathematical rule, always you need to remember this. Acha, just wait, I want to discuss about it. Acha, if we think about the linear equation, just wait. M equal to actually, in case of linear equation, what is the value of M and what is the value of C? Actually, this is the mathematical equation. Okay, I describe this. What is represented by that? Never check it. This is the mean of X. Mean means the average of all X. I think all of you know that how to calculate the average of all the X, means average of experience. Now, what we write over here we check that within open and first bracket, this part, this, check it, carefully check it. Xi means there are multiple X values, X0, X1, X2, maybe Xn. We calculate the difference from each, mean difference from each X value. Means actually here at first we calculate the mean difference of each X. Same thing in this part. In case of NumPy array, Xi means Xi minus mean of X means we got a mean difference for X0, we got mean difference for X1. So we got a list of mean difference values for feature. Same thing, here we calculate the mean difference. The mean of Y means the output mean, means salary average. Mean difference of all the salary. Then what we do? We calculate the multiplication, the mean difference between x and mean into mean difference of y. Multiply this. After that, what we do? We calculate the sum of all the mean differences. So what is this part? Actually, this part represents the sum of multiplication of mean differences of x and mean differences of y. And divided by what is this part? देखो xi, if you observe this part, the xi, the mean difference of x to the power, caret symbol represent to the power. The mean difference is square sum, isn't it? So here, what we do? Actually, at first we calculate the multiplication of mean differences of feature and mean differences output. Then we calculate what? After that, we calculate the mean differences square. Isn't it? Mean difference square sum. The mean difference square sum is called variance. This is called variance. And means this part. Means this part is called the variance sum of mean differences square. And what is covariance? Actually, this part is called the covariance. So ratio of the covariance and variance equal to the coefficient value. Got it? Actually, that is the mathematical background of this AI algorithm. But don't think that we need to calculate, we need to working with complex mathematics. No. Actually, all the things are already implemented. Just we need to know that how to use this and how to calculate the intercept value. Oh, there is a mistake. That's right. The C equal to mean of y minus m into, after calculating the m into mean of x. So after calculating the ratio of covariance and variance, after that we can calculate the value of C. Obviously, if anyone think that no sir, without using the linear regression built-in class, I want to solve the problem from the scratch. Obviously, you can do it. But remember one thing, for every process, you need to define a function. After that, you need to calculate this using the x numpy array and y numpy array. So if you calculate the value of m and c programmatically, then you can calculate the value of y for any x. All of you got it? I share a documentation. Okay, what is variance, what is covariance? I share an Word document in your WhatsApp group. Later, always, sorry, you need to remember this. Is it clear to all? Any question, any doubts?
No, sir.
আচ্ছা, এবার মনে পড়েছে সবার রে, what is variance, what is covariance?
As a
Yes, sir.
আচ্ছা, so actually inside the linear regression class, all the things are already implemented. Just what we need to do? Now we need to know that what are the process. Is it clear to all? Based on the problem statement, at first we need to think about the AI algorithms. Obviously, maybe for writing the program, not like this. Obviously, you need an idea about the AI algorithms, and when you go for the interviewer asks you the background of the AI algorithm. Be prepared for that. Now we need to know that using the AI algorithm, when we train our model, what are the steps to create the machine learning model? Remember one thing, here we are working with predictive model. Don't think that the model always predict the result with 100% accuracy. It is not possible. That's why what we need to do, after creating the model, we need to test our model. Why we test our model? At the time, by testing our model, we measure the accuracy rate, or maybe you can measure the error also. By measuring the error, you can calculate the accuracy, or maybe by measuring the accuracy, you can calculate the error, isn't it? So, if in any data set, if there is a single data set, if you got the training data set and test data set separately, no problem. But if there is a single data set, at that time, what we need to do? At that time, you need to generate the training data set and test data set. But we need to know that why. Why we need to generate the training data set and test data set? Because if why we need to generate the training data set and test data set separately? Why? Because if we train our model, train and test our model using same data set, using the data set, using this data set, you train your model, and at the time of testing, using the same data set, you test your model. Obviously, at that time, most of the cases, it will predict the result. There is a chance you predict the result with 100% accuracy. That is called overfitting criteria. Just like a oversmart people, sometimes execute, most of the time do some mistake, isn't it? That's why to resolve this overfitting problem, what we need to do, we need to train and test our model using the separate data. If the training data and test data separately available, no problem. No need to generate the training data and test data programmatically. But if you got a single data set, at that time, what we need to do, you need to generate the training data set and test data set. How to generate if there is a single data set, as for my program example, there is a single CSV file. At that time, what we need to do, we need to generate the training data set and test data set. How to generate the training data set and test data set? There is a built-in function. The function name is train underscore train underscore test underscore split function. Using that function, split the x values and generate the x train and x test. This is a built-in function. If we pass the first parameter, x, generate the training data and test data for x. Then, by splitting the y values, generate y training data and test data. Means, if you split this, maybe split in this position, okay? So, by splitting the x values, we got these x values. Maybe using these x values, we train our model. So, represent by the variable x train. And by splitting the x values, we got x test data. Using x test data, we test our model. Same thing, using these y values, by splitting the y values, we generate y train. And maybe these values, these y values, we use for testing purpose, y test. Isn't it? Now there is a big question. how much data we use for training purpose and test purpose. As per the machine learning convention, data analysis convention, at least we need to use 70% of the data for training purpose. At least means you can use 80% of the data training purpose also. 80 or 90% of the data training purpose also, no issue. But we need to use at least 70% of the data for training purpose. Okay. Means we use 30%. If you use 70% of the data for training purpose, means 30% of the data for testing purpose. How to maintain this? In case of train underscore test underscore split function, there is a built-in parameter test underscore size. Maybe test underscore size equal to 1/3, or maybe you can write 0.3 also. If I mention the test data size, no need to mention the training data size because rest of the data we use for training purpose. Okay. Is it clear to all?
Yes, sir.
Any question? Acha. Next, there is a big question. If you observe the data set, maybe we train our model using these experience values and using these salary values. If we train our model using these experience values and salary values, after that, if we are trying to predict the salary greater than 4.1 years experience candidate, at that time, there will be a problem. At that time, there is a chance of wrong prediction. Why? Because if you train your model using this data set, means our model have experience for 1.1 experience till 4.1 year experience. After train our model, maybe you are trying to predict the salary for 5 years experience. Obviously, for calculating the 5 years experience result, our model don't have any experience. So at that time, there will be a chance of wrong prediction. That is called underfitting criteria. I repeat once again, maybe when we split the data, at that time, sequentially we split the data. First few rows we use for training purpose. Okay. So if we train our model using this data set, our model don't have any experience for calculating the salary for the experience greater than 4.1 years, isn't it? So at that time, if you predict the salary for 5 years experience, there may be a chance of wrong prediction, and this is an underfitting criteria. To resolve this problem, what we need to do? To resolve the underfitting criteria, what we need to do? If we split the data by selecting the rows randomly, means when we split the data at that time, we split the data by selecting the rows randomly, means when we generate the training data, select this row, this row, this row, and this row. So at that time, we observe that in this way, by selecting the rows randomly, if we generate the training data and test data, there is a mixing of higher experience values and lower experience values. So the underfitting criteria resolved. Here we split the data by selecting the rows randomly. But how? We select the rows randomly. Obviously, we need a randomly selection algorithm. How to set the randomly selecting rows algorithm in the train underscore test underscore split function? Okay, there is a parameter random underscore split. random underscore state may be equal to 42. This is also status code. When we discuss about the matplotlib, I discuss about it. Different status code represent the different AI algorithms. Is 0, 1, 21, and 42. Okay. So actually random underscore state, that is the status code. This status code represent an algorithm. Using this algorithm, when we split the data by selecting the rows randomly, isn't it?
Yes, sir.
So in this way, we resolve the underfitting criteria. So at first, we need to split this. If we split the data, we got the training data and test data separately. I repeat once again, in case of AI data analysis program, if you got the training data set, test data set separately, at that time, no need to split the data. But if there is a single data set, by splitting the data set, you need to generate the training data set and test data set. So we got X10, Y10, X-test, and Y-test. After that, what we need to do? When we generate the training data set and test data set, after creating the model, we need to train our model using this training data set. How to train our model? There is a built-in function, fit function, and we need to pass X10, Y10. Fit is a built-in function. Fit means we feed the data into our model. Means when we call the fit function, at that time, our model trained for that type of data set. And when we train using the training data, I repeat once again, fit is a built-in function. When we feed the X10 and Y10 into our model trained for that type of data set. And the linear regression class, inside the linear regression class, the fit method already implemented. And when we feed the data, actually our model calculates the value of M and C both. Is it clear? After that, what we need to do? After that, we need to test our model. Why we test our model? For measuring the error. How to measure the error? To check the accuracy of our model. This is the way. After training,
Sir, can you explain the feed function once again?
yes, fit is a built-in function. Fit means we feed the data into the model. Fit is a built-in function. The fit function already defined inside the class linear regression. And what is the parameter of the fit function? The X10 and Y10. So we feed the X10 data, Y10 data means we feed the data inside the model, means our model experience for that type of data set. Maybe think in this way. If I told you, please tell me, students, what is the value of this? At that time, what you do? At that time, at first, you need to read the data, isn't it? So you read the data means your brain experienced for that type of data, isn't it? That is the meaning of fitting the data. At first, you need to read the data. After that, you can calculate the result using some mathematical rule, isn't it?
Yes, sir.
So read the data means feed the data and process it. This is already implemented inside the feed function. Is it clear to all now?
Yes, sir. Yeah.
Thank you for asking me the question. Now, X second, huh? Uh, just wait. Huh. So after fitting the data, when we feed the data into the model, actually our model calculate the value of M and C. Okay. Now, how to measure the error of our model? To measure the error of our model, what we need to do? Actually, this is the way. The sum of the experience values available in the X test. At first, we need to predict the salary value for each experience value available in the X test. How to predict the Y value for the experience available in the X test? There is a built-in function, predict. Predict is also built-in function, which is defined inside the linear regression class. What is the functionality of the predict function? Actually, predict function predict the Y value or salary value. If we pass X underscore test, just we pass the X underscore test as a parameter to the predict function. What is the functionality of the predict function? Predict function predict the Y value for each X. X means the experience value available in the X test. There are three X values. So, our model predict three Y values. If there are four X values, obviously our model predict four Y values. Like this. Maybe the predicted Y values represented by the variable Y pred. Maybe the predicted Y values are like this. Okay, for 4.5 years experience, the predicted Y value, that is maybe 61,000. Maybe. Don't think that always you got the same output. No. Due to the coefficient value and due to the intercept. Maybe for 4.9 years experience, our model predict that the salary is 68,000. For 5.1 years experience, our model predict that is 66,000. Okay. So these are the predicted value by our model. To measure the error, what we need to do? We need to compare this predicted Y value with the actual Y value. What are the actual Y value? Actually, these are the actual Y value. Okay. Now, if we compare the actual Y value and predicted Y value, we got some error. For each cases, if there are 3 test cases, so we got 3 errors. If there are 100 test cases, we got 100 errors. If we compare, actually these are the actual Y value and these are the predicted value by our model. If you compare these two values, in case of first case 61,000 something minus 61,000, you got a positive error. Maybe positive error represented by U1. In case of second case 67,000 something minus 68,000. Obviously at that time you got some negative error. In case of third case 66,000 something minus 60,000. So here also you got some positive error. And maybe the positive error represented by E3. So in some cases, we got some positive error. In some cases, we got some negative error. but how to calculate the error of our model. See, after calculating the error for each cases, we need to calculate the average errors, average of all the errors. But is it possible to calculate the average for any negative value? No. At first, we need to discard the negative value. Then we calculate the errors. How to discard the negative values? By taking the absolute value. By taking the absolute value, you can discard the negative value, isn't it? Or maybe or maybe by calculating the square of each error, you can discard the negative value. Okay, if you calculate the square of each error, E1 square minus E2 square, E3 square, so negative values are discarded. And this is called, if you calculate the square value, this is called square error, square of each error. If you calculate the square of each error, all the negative values are discarded. After that, now all the values are positive value. So after that, you can calculate the mean or average of all square error. And this is called mean square this is called mean square error. Okay. But it is the average of all the square error. Now what we need to do? We need to calculate the square root of this mean square error. And if you calculate the square root of this mean square error, then it is called root mean square. This is called root mean square error, or abbreviated as RMSE. So if we calculate the root mean square error, I think all of you got an idea about it. If the error values are less, obviously our model is good. But remember one thing, by taking the absolute value, you can calculate the mean of all the absolute values. Then this is called absolute mean error. At that time, obviously, no need to calculate the square root of absolute mean error, isn't it? This is called root mean square error. So is it clear to all? What are the steps? Don't think that for every AI algorithm, by using the AI algorithm, when we create our machine learning model program, at that time, always we need to use root mean square error, not like this. In case of classification, the measurement of error and accuracy are different. Later we discuss about it when we are working with classification AI algorithms. At that time, we discuss about how we measure the accuracy and error of our model. But in case of linear regression, linear equation, these are the steps. I think all of you got it. What is root mean square error? What are the important questions you face in case of simple linear regression? First of all, just now I discussed about it, how to calculate the coefficient value, coefficient m value, how to calculate the intercept value. At that time, you need to talk about the variance and covariance value. You need to remember this. After that, in case of linear regression, how to measure the error. for discarding why we calculate the square error, why we calculate the absolute mean error. Not, not like that, directly we calculate the average of all the errors. Why? Obviously, at that time, you need to discuss about it. When we calculate the error, sometimes we got the positive error and sometimes we got the negative errors. To describe the negative values, there are two ways. By taking the absolute value, you can calculate the error, or by calculating the square value, you can discard the negative value also. After that, if we calculate the mean, after calculating the square value, if we calculate the mean, then this is called mean square error. After calculating the mean square error, if we calculate the square root of this mean square error, then this is called root mean square error. Is it clear to all?
Yes, sir.
Now I want to implement this programmatically. I share this screenshot. Just wait. In your WhatsApp group. And I share the data set also. Just wait. Ball capital. Oh, sorry. Copy honey. Eta na ek second. Just wait. And I share the CSV file. Says download it and save it in your directory, program directory, anywhere in your hard disk. Now check your WhatsApp group. I think all of you got the CSV file. Now I go to the Spider editor. If I want to implement this programmatically, how to do that? I create a program. Save this program in the same directory, maybe E drive, JIS folder, JIS second phase. Okay. Obviously, when you are working with the machine learning program, at first, the same pandas module. Import pandas as okay. Using the read underscore CSV function, we read or extract the data from the CSV file. I think all of you know that. So I think all of you got an idea why we learn NumPy pandas at first. Then we go to the AI and machine learning data science program. Actually, we implement the AI algorithms using machine learning module program. Okay. So read underscore CSV, and what we pass, check it. salary underscore data dot csv. That is our file name. Salary underscore data dot csv. Read underscore CSV function, read the data from that CSV file and store it in a variable df. And actually it will generate the data frame. If you execute the program, I think all of you know that already we are working with data frame. This is our data frame. These are the year of experience values. These are the salary values, isn't it? Now from this, we want to extract the features. How to extract the features? If we think about the feature, the 0th column, all the rows are the feature, isn't it? So how to extract this? It may be X. I want to store all the features in the variable X. How? From the data frame using ilog method, I extract all the rows. Colon, there is no start row index, there is no end row index, means all the rows, comma, only 0th column values. Obviously, you can write in this way. Actually, I want to generate a feature like a single column, multiple rows. The dimension is very much important over here because each row represents a single categorical feature. Each row represents a single categorical feature. If you extract the data in this way, in a single row, multiple column, it will not working properly. Dimension of the data is very much important in case of AI ML program. But remember one thing, if you extract the data after executing the program, check the data type of the variable X, that is data frame, isn't it? But remember one thing, when we are working with machine learning program, at that time, you need to pass, always you need to pass the data in NumPy array format. So how to convert a data frame into NumPy array? Actually, there is a built-in property. The property name is dot values. Actually, dot values, because what is the data type of variable X? Check that. That is data frame. How to convert a data frame into NumPy or using the data frame, how to generate a NumPy? It dot values. So after that, if we execute the program, check the data type of the X. It will convert it into NumPy object, isn't it? So same way, we need to extract the salary values. So how to do that? Y equal to df dot ilog for all the rows. Obviously, it will extract the data in data frame format, convert it into NumPy array. So feature and the output values are extracted. After that, what we need to do? We need to split the data. How to split the data? Using train underscore test underscore split function. The train underscore test underscore split function defined in sklearn module. In sklearn, sklearn, in sklearn, there is a sub module. Sub module name is linear underscore model. From this sub module, in this sub module, actually train underscore test underscore split function already predefined. So what I write? Import train underscore test underscore split. Now we split the X values and Y values, generate the X test, Y train, and Y test. So the parameters, the same thing that just now I discussed about it. X, Y, maybe test underscore size. X underscore train, comma, X underscore test. By splitting the, you can give any variable name. Don't think that the variable names are predefined, not like this. You can give any name of your variable. By splitting the data, we got training data, test data. That's why sequentially training data and test data. 70% data over here, 30% data over here. Same thing. So after that, if you execute the program and you need to observe the data set. Oh, linear underscore mon. There is a mistake. I cannot input the name TRAI and test underscore. Oh, not linear model. The name is model underscore selection. That's a mistake. The submodel name is model underscore selection. Okay. There is a mistake. Not linear underscore model. Model underscore selection. Yes, see. Spelling mistake. So whenever you got any error, just read carefully the error message. By observing the error message, you can debug your program very easily. Okay. So after that, if you observe the training data and test data, maybe training data, X10 and just wait. Now, if you observe the actual data frame, now if you observe the training data, at first for 1.1 year experience, 1.139343. In X10 0th row 1.139343. Then not like that sequentially, randomly. Then select this experience, 2.2 and this one. Check it, 2.239891. Then maybe 5.1. So 6 is 0 to 9. So here, by observing the training data set, what we observed, when we split the data by selecting the rows randomly, not sequentially. Is it clear to all?
স্যার আপনি যে বলেছিলেন ওই 70% ট্রেনিং ডেটা নিতে হবে মিনিমাম, ওইটা স্যার এখানে কিভাবে দিচ্ছে একটু বলবেন?
That if you observe the main data frame, how many rows are there? Start from 0, 29. How many rows? Ball?
29 sir.
হ্যাঁ 29 করতে 0 से start হয়েছে তো 0 থেকে
Oh,
start
হ্যাঁ,
হলে
30 30
30
30 30
So if you observe the extend data, how many extend data are available? 0 to কত রয়েছে 20,
হ্যাঁ স্যার
21.
21 sir.
Now calculate the 70% of the 30 rows. কত হচ্ছে 70% of the 30 rows কত হবে রে? Calculate
21 sir.
21 স্যার
21 তাহলে বোঝা যাচ্ছে।
হ্যাঁ স্যার। আচ্ছা
If
যদি
you
আমি এর থেকে বেশি নিতে চাই মানে ট্রেনিং এর জন্য ডেটা, ওটা স্যার কিভাবে করা যাবে?
এখানে ধর এটাকে 0.2 করে দিলাম মানে 20% টেস্ট ডেটা তাহলে 80% ট্রেনিং ডেটা।
হ্যাঁ স্যার।
After executing the program, start from 0, 23. So how many rows are there? 24.
24. Yes sir, got it.
Means by changing the test underscore size parameter value, you can increase the training data size, isn't it? Is it clear to all now?
Yes sir.
Acha.
ইয়েস স্যার
Second দ্বারা। Now, what we need to do? We need to create a machine learning model. The machine learning model is using linear regression already implemented in a class. The class name is linear regression. It is implemented in the sklearn module. So here I write from sklearn. What is the submodule name? sklearn dot linear underscore model. In this submodule, implemented as a class. Now we need to create a model, means what? We need to create an object of that class. So how to create an object of that class? Maybe RG is an object. Linear regression. We create an object. The object name is RG. After creating the object, linear regression, this is an object. Create an object of that class. Means, create an object of that class means we create a model. After creating the model, what we need to do? After creating the model, we need to feed the training data into the model. This is a class. We create an object of the class. We need to feed what? Extend, y10. So means in line number 12, we train our model. Our model now experienced for that data set, for the training data set. If we train our model, let's see, when I feed the data into the model, at that time, actually inside the model, the coefficient, if the equation is mx plus c equal to y, the m values and the intercept values are calculated inside this class. How to access the m value? Let's see. Maybe the coefficient name is m. The rg dot coefficient underscore. It is a built-in property. After that, maybe then they write in this n equal to Same thing in case of C, it is called intercept RT dot. After that, maybe I write in this. Now, if I execute the program, allowed for some spider call. Let's say m equal to this value. And what is the value of C? 5,000 something, isn't it? So if we retrieve, when we feed the data into the model, actually internally all the functions are predefined based on the variance and covariance. It will calculate the value of M coefficient and calculate the intercept value C also, isn't it? So if we know the value, কিছু বলছিলি বল?
না স্যার ঠিক আছে।
আচ্ছা, if we know the value of M and C, obviously after that anyone can calculate the Y value for any X, isn't it? Now we need to know that how to check the error. Obviously at first, what we need to do for calculating the error? At first we need to predict the Y value for each X available in the X test. Check it, these are the X test values. Here I use 20% of the 30 rows data for testing purpose. So 20% of the 30 rows means the 6 values, 0 to 5. So here, what we do, for these 6 values, we predict the Y value. Okay, maybe I store this value in a variable Y underscore predict. The Y underscore predict equal to, how to predict this? What is the name of the object? RG dot, there is a function predict. We pass the X-test values as a parameter to the predict function. And our model predict the Y value for each experience value available in the X-test. So now if I execute the program, check. In case of X-test, there are 6 experience values. And for these 6 experience values, our model predict that the salary will be like this. Now, what is the actual salary? Actual salary available in Y test. So, test.
স্যার এখানে rg.coef আর rg.intercept ওগুলো কি কাজ করছে স্যার?
কোএফিসিয়েন্ট মানে কি বললাম? এই যে যদি ইকুয়েশনটা, just if the equation is looks like that, যদি আমার ইকুয়েশনটা এই ধরনের হয়, তাহলে তো অ্যাকচুয়ালি আমার স্যাম্পল, আমাদের টার্গেটটা কি? হোয়াট ইজ আওয়ার টার্গেট? We need to calculate the value of M and value of C, isn't it? How
Yes,
to
sir.
retrieve the value of M? Actually, it is a built-in property.
Okay,
Wave
sir.
underscore, and that is the intercept.
Okay, sir. Got it.
Or anyone, any question? Acha. Now we predict the uh, y value for each experience value available in X test. So if you open the predicted y values and what are the actual y values? Actually, these are the actual y value, isn't it? For these experience values. Now, if we compare this one and this one, this one and this one, this one and this one, by comparing the actual salary value and predicted salary value, we measure the error, isn't it? So, how to do that? No need, like just now I discussed about the mean square error, isn't it? No need to calculate anything manually. There is a module I write from sklearn import import matrix. Spelling is very much important. or there is another class, the matrix. Here I write matrix. Acha, acha. It is a sub model. Sorry. Well, all the functions are available. Mean absolute error, mean squared error. Maybe you can use mean absolute error also. Maybe I use mean square error. And the mean square error is a built-in function in this module. So matrix dot mean square error, not y2. Actually, I stored it y test variable. By comparing the actual y value and predicted y value, we got a mean square error. Maybe I'll store it in a variable MSE. Okay. After that, if you want to calculate that is the mean square error. If we want to calculate the root mean square error, obviously we need to calculate the square root of this value. How to do that? Import numpy as np. So np dot sqrt square root of MSE, and we got RMSE, root mean square error. After that, by printing the RMSE, you can check the root mean square error. Now, if I execute the program, check the root mean square error. It will show you. Just do it. 7,000 something. Why? Actually, here I generate the data. Achha, check it. Maybe I change the status code. Status code equal to random state status code. Almost same, no issue. Achha. Here, actually, I generate the data set. If you observe the data set, there are many errors like if you observe the data set, Just wait. If you observe the data set, all of you observe that if for 2 years experience salary is this, is it possible? No. That's why we go. Variance is different. Here 3946 increasing, then decreasing again, still increasing. So actually, here you observe that in the variance, there is a different trend. That's why the error is increasing. We got a 7,000 error. But remember one thing, if you think about the minimum salary, minimum range, if you think about the range of the salary, minimum is and the maximum is, we observe that the salary values are very high salary. Out of 39,000, 7,000 is not an issue. And later I discuss about it. When we are working, maybe you are working with a complex mathematics, you calculate something. When you calculate the result using the big range values, obviously at that time, if you got any error, you got a big error. But from the big range values, if we generate the lower range values, using the lower range value, if we execute any mathematical equation, mathematical operation, at that time also you got some error, but you got some small range error. Means from the high range values, you can generate a lower range value also. Why? To reduce the error. To reduce the error, you can generate a lower range value from the high range values. This is a way of optimize our model. All of you got it? Later I discuss about it, how to generate the lower range value from the big range values. Now, maybe the RMSA is this. After that, here, if you, is it clear to all?
Yes, sir.
Here, after creating the model, you can calculate the salary in two ways. By using the value of M and using the value of C, you can calculate the salary. Like, maybe you need to calculate the salary for 2.3 years experience. 2.3 years experience candidate. Maybe SAT equal to mx plus c equal to y. So m, this is the m, the coefficient value, m into x, that is 2.3 plus what? C value, that is the c. So in this way, you can calculate the salary value. After that, maybe a print salary for 2.3 years experience equal to sal. Now, if I execute the program, check the salary. In this way, you can calculate the salary. Another way to calculate the salary, maybe using the machine learning object. Sal equal to, what is the name of the object? RG dot predict. Now we need to pass the experience value, 2.3 years experience. how we pass this experience value as a parameter to the predict function within open and close square bracket T2.3. Why we need to pass this 2.3 value within double open and close square brace? Because the dimension. Always we need to think that what type of data we use for train our model. That is the extend data. If you think about the single experience value, in 9.5, it is a collection of 0th row and 0th column. Single row, single column means that is two-dimensional data. How to represent the two-dimensional data? If you pass this, means this is a single value, not two-dimensional value. But if you put this value within open and close, double square brace, the first square brace means 0th row, second open and close represent the column. Okay, that's why always when you predict some result at that time, you need to think about the dimension. So after that, maybe I print now salary equal to this sal 2. After that, execute the program and now compare both the salary. What is the output over here? Both the salaries are same. So is it clear to all? Kidako, obviously mathematical knowledge is important. What is the AI algorithm you need to know? But without writing, without computing any complex mathematics, I predict the output. And remember one thing, maybe you need to check that whether your model is working properly or not. How to check it? You can visualize the model also. How? Maybe. Achha, is it clear to all? Anyone, any question, any doubts?
No, sir, clear.
If we visualize the data, maybe there are some experience values available in X10, and these are the Y10 values. You can do this using the test data also, no issue. Huh? Maybe using X coordinate, I represent the experience values. And using Y coordinate, I represent the salary values. Okay. So when X equal to 9.5, salary equal to this. When X equal to this one, salary equal to this. When X equal to this, then salary equal to this. So we got some data point in two-dimensional graph. Today we learned how to generate a plot or graph, isn't it? Using matplotlib. Maybe I think all of you got the meaning of this line. Using X coordinate, we represent the experience, the available in the X10 data. So that is the parameter X10. And using Y coordinate, we represent the Y10 data. And maybe I want to represent his data point using the red star symbol. Okay. X10, Y10. and represent each data point using red star symbol. Each each experience values and salaries values represented by the plot. After that, x-axis level. So now if I execute the program, now go to the plot section and check the output. Actually, the red star symbol represent the actual data points. But actual data points are not in the straight line. But remember one thing, actually linear equation represent a straight line. But actual data points are not lies in the straight line, isn't it? When we got a straight line, for each experience value, if we predict the y value, using x and this predicted y value, we got a straight line. Why? Because our model created using the linear equation. So maybe I predict the y value, predict the salary value for each experience available in X10. The RG is the model name. Predict is a function. Predict is a function. We predict the y value for each experience available in X10. Okay. Now I draw a line. PLT plot using X10 values and the predicted values. Now if I draw a line, now the graph looks like that. Because here I got a straight line. Why? Because for each x experience value available in the X10, we predict the y value using our model program. That's why all the y values are in a straight line. Using these y values, actually, we got that type of slanting line due to the intercept. And by observing the model, we observe that all the data points are nearer to the straight line. So from that idea, we conclude that our model is good. Maybe there are some error, not like that all the actual data points lies in the straight line. If all the actual data points lies in the straight line means your accuracy rate increasing. And if the scenario is like this, maybe this is the graph. If any data points lies far away from the straight line, maybe this data points lies over here, means at that time you need to think that there is a huge error. That's why the actual data point lies far away from the straight line. Actually, when we are working with different data set, at that time, obviously, we implement the AI algorithms. But after implementing the AI algorithms, we need to observe by visualizing the model in this way. By visualizing the model, we can conclude that whether our model is